working on reducing radicals, we talked about what happens when we have a negative underneath the radical sign. Now, what we did is we decided that we were going to stop and we weren't going to go any further. We said we couldn't deal with it yet, right? So now the time has come. We need to learn about what we do when we have a negative underneath the radical. Okay? So, our essential question today is how do we use operations with complex numbers? We're going to learn what a complex number is. Let's see here. And how we use our operations. Okay. So, go to the next page. All right, how can we take a square root of a negative number? All right.
Do you have to put it into like a decimal?
Nope. We are going to be dealing with something called imaginary numbers now. Okay? We can take the square root of a negative, but what we're going to be dealing with is imaginary numbers. Now, we have a very nice calculator that does all of this for us. However, we have to do one thing in order for the calculator to work correctly. Okay? So I need everybody to go home. I need you to go to System Info, please. And now I can't show you any further, so you're going to have to follow along from here. Please go to System Settings. And you are going to go down to real or complex. And you're going to change that to rectangular. Okay?
What does that do?
That's going to make it so we can deal with imaginary numbers in the calculator. Okay? So, first thing you do when you sit down for the Regents exam is you take your calculator, you go to your system settings, and you change your real or complex to rectangular.
Are you supposed to remind us?
No, I'm not allowed to remind you, so you need to be able to remember to do this. When I do press to test on your calculators, it goes to defaults. Okay? Which means this will not be ready for you in rectangular mode. You have to change that yourselves. Okay, so this is something you will have to remember what to do. Okay?
Can we leave it in rectangular mode? Will everything still come out?
Yes, everything will be fine. Okay? All right, so everybody's in rectangular mode. It's going to say apply to system to current document settings. Hit yes. Please add a calculator page to your lesson. Control-I, add calculator page, please. Okay, I want everybody to put in the square root of -1.
Like an I. Is that like a
You changed your language to Spanish. You need to go back to system settings and change it to English, please. Okay, so when you put the square root, when you put the square root of -1 in your calculator, what'd you get?
like a school?
An I, a cool looking eye, right? Your cool looking eye is located right here. Okay? This I stands for imaginary. The square root of -1 is I, and I stands for imaginary. Okay? So, every single time you see the square root of -1, you are going to tell me I. Okay. Good. So now let's talk about radicals in general when I have a negative underneath. Okay? When you have a negative underneath the radical, the first thing you're going to do is you're going to pull out the I. Okay? And the reason we're going to do that, if I look at the square root of -4, if I told you I had the square root of -1 times the square root of 4, what would you tell me that equals?
I do. Square root of -4.
Square root of -4. If you multiply them together, it's just the square root of -4, right? Is that what I started with?
Mm-hmm.
Okay, so I can break them apart like that, no problem. Right? What's the square root of -1? What's the square root of 4?
2.
So what's my answer?
I do. 2.
How am I going to say it?
2i.
2i. How do you feel about that?
Decent.
Decent? Okay.
I think
Now, you don't have to break it up like this every time. The way I do it, and I've been dealing with it longer than you guys, but every single time I see a negative, I make it positive and put an I up front. So if I'm looking at this negative square root of -16, I'm going to say I square root of 16.
4i.
4i. Good. So I want you to do the next 3 examples, okay? Give it a shot. So let's go over this. Jana, square root of negative 16, what'd you get? 4i, perfect. You can see here, let's have Olivia.
Yes.
Square root of negative 18.
There's 2 square roots 9.
How'd you break up 18?
And 2 and 9.
Square root of 2.
Yeah.
Square root of 9. Oops. I don't want to do that, do I? And I'm going to have out here an I, right? So that's our negative. Okay. Can you reduce the square root of 2?
No.
What's the square root of 9?
13.
So this needs to be 3i square roots of 2.
3 square roots of 2i?
3 square roots of 2i, no. You gotta have the measure number out front.
Wait, Ms. Gucci, if you didn't put the I after the 9, but you made it negative to begin with, would it be the same thing?
Yeah.
Or,
Okay, Megan, square root of 72.
I broke it into negative 36, or the square root of negative 36, and then the square root of 2, which equals, I didn't get that far yet.
Square root of negative 36 is what? 6 I. Perfect. Okay, how do you feel about imaginary numbers so far?
It's gonna be easy.
Easy, right? Doesn't get much harder. Pretty simple stuff. Okay. Okay, next page. So, if negative 1, square root of negative 1 equals I, what does I squared equal? Be careful. Careful.
I squared.
Negative 1. And why is it negative 1?
Because
You're just taking the square root of
Yeah, if you square this side, you square this side, you square, what happens? Square root. Yeah, it stays the same. So radicand stays the same, you're just removing the radical sign, okay? This is a very important rule. You have got to know this. I squared equals negative 1. That's going to become very, very important when we start working with the operations, okay? Okay, so it used to be on the 84, if I had an exponent that was larger than 4, my calculator gave me issues, okay? With the inspires, this isn't a problem. I can put I to the millionth power and it will tell me what it equals. I can put I to the 600th power to tell me what it equals. On the 84s, what we had to do is we had to divide it by 4, find the remainder, raise I to the remainder, and then hope I get the right answer. Which way do you want to do that? This way. Thank you. All right, so using your calculator page that you entered earlier, I want you to find I to the first, I to the second, I to the third. Imaginary numbers are cyclic, which means they go in a cycle. They go around in a circle. Now this is cyclic by 4. Okay, so you see a pattern after you do I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth. You're going to see the pattern, okay? So I want you in that calculator page to go through I to the first, second, third, fourth, fifth, sixth, seventh, eighth, and I want you to find that pattern, okay? Okay, so what'd you get for I to the first power? I. Good. What'd you get for I to the square? And you should know that by heart. What'd you get for I cubed?
negative I.
Negative I. And what did you get for I to the fourth?
1.
Good. Now, I to the fifth?
I.
I to the sixth?
Negative 1.
I to the seventh?
Negative
I to the eighth?
1.
You see a pattern?
Oh, that's why.
I negative 1, negative I 1. I negative 1, negative I 1. I negative 1, negative I 1. It goes by 4s. Okay? Now, like I said, you used to have to divide by 4, find the remainder, and do it this way. I want everybody to put I to the 636 into your calculator. Are you ever going to get a multiple choice question on one of these and your Regents wrong?
No.
You had better not. Okay. Okay, let's see. We good? Any problems? We're okay with this? We know how to press buttons. Next page. Okay, complex numbers. Complex number is the sum or difference of a complex number or an imaginary number and a real number. Give me an example of a real number. 1, 5, -3, -12, 15. All real numbers, okay? Give me an example of an imaginary number. 2i, I, -5i. All imaginary, okay? So what this is it's a combination. Remember we talked about composites? It's a composite of a real and an imaginary. So an example of this, 3 plus 2i. That's a complex number. -4 minus 2i. That's a complex number. You notice what form I'm putting these in? What's going first, what's going next? Yes. It always has to be in this form, a plus bi, where a is the real number and b is the imaginary. Okay, that's important that you know that you follow that form. You're always going to put the real number first and the imaginary next. Okay, so you might want to enter that in. All right, so now we're going to start talking about operations: addition, subtraction, multiplication, division. Calculator. All right, now this says we have to adjust it. We already adjusted it, right? So you may want to down here say, what did you have to change? You had to change system info, and you changed what? I think what did it say? Real or complex, or real
Rectangular.
rectangular, and then you changed to rectangular. Okay, so maybe make a note of that so you know what you have to change, because that's important.
Oh, it was system info, then real and complex, and then
System info, real and complex, and then rectangular, right? So in here, real and complex. Okay? I know it's hard to read, sorry.
What does it say?
Real and complex. That's what you changed. So you went to system info, system settings, and went down to real and complex and changed it to rectangular. Okay? And that's the first thing you're going to do when you sit down to take your Regents exam. Right? Good. Okay, next page. Adding complex numbers. It's as easy as putting them in the calculator. Okay, this is the calculator page. I want you to put in, I don't know, -7 plus 4i plus 8 minus 2i. Add those two complex numbers together. You know where your I button is, right? You know where your addition sign is? This should be easy.
1 plus 6 times I.
1 plus 6i?
1 plus 2i.
1 plus 2i? Should you put a number in wrong, Megan?
Probably.
Okay. 1 plus 2i is correct. Easy? Any problems with adding complex numbers?
No.
Okay, so all you're doing here is you're combining like terms. -7 plus 8 is 1. Plus 4i minus 2i. Okay, so that's all it is. So if you had to show your work, this is how you would do it.
Oh, I had plus 2i.
Any problems? Easy, right? Okay, good. Next page. Let's talk about subtracting complex numbers.
So is it complex, just imaginary?
Complex is an imaginary combined with a real.
Oh.
Okay. Okay, subtracting. How is this one different? Parentheses. Why do I need parentheses?
Do you distribute on this?
Yes. Remember when we were subtracting, when we subtract polynomials, you have to do the keep, change? This is no different. Okay? So the set of parentheses in here is so that it knows it's subtracting the whole quantity. So what it's going to do is it's going to do 3 plus 4i minus 2 minus 5i. Distributes through that negative. Okay? So, I don't know, let's see here. Put 4 minus 6i minus 8 plus 7i.
What is that line before the 4?
That's just cursor.
-4 minus 13i.
That's what I had.
Okay, so this, all it is, if you have to show your work, which you will, on your homework I'm making you show your work, you're going to do 4 minus 6i minus 8 minus 7i. Distribute through that negative, right? Combine the like terms, we get negative 4 minus 13i. Yes?
So instead of 8 minus 7y, then you just be adding instead?
Correct. Any problems, questions, concerns?
Where do you keep changing?
Keep, change, change.
So if I had to do that, I would have to do that.
You guys learned subtracting polynomials in 7th grade, 8th grade, 6th grade, 7th grade, 8th grade, 9th grade, 10th grade, and now again in 11th. This should come second nature. If it doesn't, I don't know what to say. We need to make it, okay? Okay. Any problems with subtracting? Are we okay? Next page. Multiplying complex numbers. Let's say I have 2 plus 4i times negative 3 minus 2i.
We have to FOIL.
Very good. I was just going to ask that question. If you're doing this by hand, because it's like 2 binomials, right? You have to FOIL. Okay? So put this in your calculator, and then we're going to do it by hand. So you see how we do that as well. Okay, so you got what?
2 minus 69.
Okay. Now, let's see how we do it by hand. Negative 6 minus 4i minus 12i minus 8i squared. FOIL. Any problems with that? We know how to FOIL, right? Okay. Okay, so now I'm going to combine my like terms. Negative 6 minus 16i minus 8. What's I squared equal?
Minus square root.
No, what's I squared equal?
Negative 1.
Okay, you replace I squared with negative 1. That's what it equals. Okay, this is important. You'll see this time and time again. It's usually a part 2 or 3 question where you'll have to show your work and show that substitution for negative 1. So this is important. Okay? So I get negative 6 minus 16i plus 8. So we get 2 minus 16i. Okay? Now in your homework, I'm going to have you foiling these out by
What
hand.
is the 8 though?
Yeah, what happened there?
What's 8 plus negative 6?
Up to.
Okay? Any questions? Concerns? Okay. Division. You will be doing strictly on the calculator. Let's try 6 minus 3i divided by 2. I. Now, when you're putting this in your calculator, I suggest putting in a fraction template first, and then the numerator and the denominator, so you cannot mess that up, okay? What do you get?
Negative 3 over 2 minus 3i.
Yeah. Negative 3 over 2 minus 3i. Any problems? Easy?
How would you get that if you did it out on hand?
It has something to do with how we break it up. These cancel. Here you get your 3 halves, and then you change the sign in the center. So, 3i.
Yeah.
Okay. That's the end of that document, right? Let's talk about one more thing. I want to talk about absolute value. So I want you to add in another calculator page, please. Add in another calculator page. You also need to know how to do the absolute value of complex numbers. So if I asked you to find the complex number of 2 minus 3i, stop talking when I'm talking, it's rude. How would you find the absolute value of that? How?
You go to the below.
Yeah, do it. 2 minus 3i.
3.60555.
You're going to go book, absolute value, 2 minus 3i, and it's going to give it to you. Okay? It doesn't get much easier than that, right? Okay, so let's talk about graphing. So I need you to open up 14b, please. Okay, so you should have 14b open. It says it's a parallelogram, you say. Graphing the sum of two complex numbers. So what we're going to be doing today is we're going to be learning how to graph complex numbers. And when we're talking about complex numbers, we said it consisted of two parts, right? The real part and the imaginary part. Make sense? Okay, so we're going to learn how to deal with those in just a moment. So, complex numbers, there's our a plus bi form, can be graphed either as points or vectors. We're going to graph them as vectors. Now, every single one of you should have heard the term vector before, correct? You all took geometry last year. You should all know what a vector is. Okay. On a graph, the real axis, which is the horizontal, okay? So x is now real. Y is going to be imaginary, okay? So instead of dealing with x and y, we're now dealing with real and imaginary, okay? So a complex number has two parts. You told me it has a real part and imaginary part, right? So if I told you 3 minus 2i, I've got 3 and negative 2i. Are you okay with that? Okay, so we're going to look at graphing these in just a second. Next page. Order pair for a point on a complex coordinate plane is real and imaginary. The complex number a plus bi is graphed. Didn't I just say all this? As the point AB. I already said all this. Okay, go to the next page. Okay, this is what we're looking at. This is in vector form. This is as a point. We will be doing it like this. Okay, we will be graphing these as a vector. Vector, where's it starting? At the origin. So if your vector is not connected to the origin, it is incorrect. Okay? You put a point at the complex number and then a vector that goes to the origin. Negative 8 plus 3i. This is how I'm going to graph this complex number. I said my real axis was my x-axis, my imaginary is my y, correct? So my real part is negative 8, so I go back negative 8. My imaginary is 3, so I go up 3. Any problems? Pretty easy, right? Okay, 2 years ago, this question was a 6-pointer on the Regents exam. 6 points if you can graph the sum of complex numbers. If you get it wrong, I will hunt you down. Okay? So yes, this is good. You understand.
Yes, I'm good.
All right. This is simple. So we're going to move through this kind of quickly. Next page, we're going to explore the addition of complex numbers. We're going to grab and drag the tips of the vector arrows to change the values of complex numbers. So here is our current problem. I've got 2 plus 4i, 3 plus negative 2i, and this equals 5 plus 2i. We know why it equals it. We see how that does it, right? That's nothing new for us. So what I'm going to have you do is I'm going to have you grab a point, or the points, and notice how these things change. See how the value of the complex number is changing? See how the sum is changing? See how this piece in the center is changing? So I want you to take a little time and see how these things change when you change the complex numbers. Okay, so play a little bit. All right, so let's take a look on the next page. The sum of any two vector quantities is equal to the result of the parallelogram that is constructed using two vectors as two consecutive sides of the parallelogram. Consecutive, you guys know what consecutive means? One after another. Parallelogram, you all know what a parallelogram is? You better. My daughter does. She's in first grade.
Her mother's a math teacher.
Does not matter. Okay, so let's put those words into what this actually is. Okay, that's not it. Okay, so go back a page. Consecutive sides of the parallelogram. Here's a parallelogram, right? This is a parallelogram right here. This is one vector. This is the other vector. They are consecutive sides of the parallelogram, correct? The sum of these is this piece in the center, which we normally call the diagonal. In this case, we are calling it the resultant force. Okay? So this is two vectors. Their sum is the resultant force, which is the subject. Okay? So you need to know these terms. Resultant force is a very important term. When you hear force, it's just talking about the vector. Okay? All right. So, describe the relationship between the two complex numbers being added and the diagonal or the resultant of the parallelogram. The result is the sum of the two complex numbers. So the resultant is the actual solution to your addition problem. Okay, does that make sense? So get this in there. Okay, next page. My hope for this, I put all of the words up here in one general area, and for some reason, they're not all showing on yours. Okay, so the ones that are not showing, what you're going to have to do is you're going to have to enter a text box and type in what these things are. Okay, so, oops. Here are your words. What I want you to do is put your words in the appropriate spots. So you're going to label your imaginary axis, you're going to label your real, you're going to label your resultant vector, you're going to label vectors 1 and 2. Okay, so if your words are not here for you to click and drag, you have to enter a text box. Who remembers how to enter a text box?
Menu.
Shape.
Actions. Text. So you're going to enter a text box if you can't get your words, okay? Real. All right, so if you can't find them up here, if they're not up there because they're hidden, just add text box and label all of these things. What are the vectors? What's the resultant? What's your imaginary axis? Okay? See? All right. So you should have had your imaginary axis as your y-axis. Your real axis as your x. Vector 2 and 1 doesn't make a difference which one is what, as long as each of them are vectors. The resultant is that diagonal, and the sum of vectors 1 and 2 is the same thing as the resultant. Are we okay?
Wouldn't the sum of vectors run to, wouldn't that just be the point, or is that the whole vector, the line?
The point, but the way it's represented is by a vector.
Oh.
Okay? Okay. Now, we already talked about subtraction, correct? We said subtraction of a complex number is equivalent to adding the opposite value. A plus bi minus c plus di is the same thing as a plus bi plus negative c minus di. That's that whole keep change thing that we talked about that you did all through junior high and high school now? Yeah? Okay. All right, so here's just an example of it. I'm not going to spend much time on that. What I'd like you to go through, don't worry about this one. Let's move on from that. I want you to roll through these examples, and I don't really care about you pulling around the points. What I want you to do is give me the sum or the difference of the complex numbers. Okay, so answer the question, and then we're going to graph on paper how we would graph these complex numbers. Okay, so take a few minutes. Are you ready? All right, so I have, this is what you're going to do on your graph paper. 3 plus 2i plus negative 2 minus 3i. What we're going to do is we're going to learn how to graph these on the graph paper, okay? So, those of you that have the regular graph paper without the 4 quadrants, or the 4 actual graphs, what I'm going to need you to do is just put x and y axes, like 4, you want 4 of them. Okay?
Only 4 problems?
Yeah. Okay, so I'm going to show you how to do the first one, and I'm going to give you a couple more examples after that, okay? So I have 3 plus 2i and negative 2 minus 3i. What axis is this?
Imaginary.
Imaginary. And you're going to label it imaginary.
Should we just put I if we want?
No. What about this?
Real.
Real. Okay, so you've got the real and the imaginary. Are we okay with that part? All right, I've got 3 plus 2i. The way I'm going to graph this is I'm going to start at my origin. I'm going to go 3 on my real axis, and then up 2 for 2i. And I'm going to put a point right here at point 3, 2, right? So this is the point 3, 2i. Now, to draw my vector, back to the origin, arrow at the point, and I'm going to label it 3 plus 2i.
Should we get rulers or something?
Huh?
Should we get rulers?
If you'd like one. All right, negative 2 minus 3i. How am I going to do this one? Perfect. So here's my point, here's my vector, and I'm going to label it. Now, I want the resultant, so I'm going to have to add these together and get my sum. And what is my sum when I add them?
It's gonna be 1 plus or minus I
1 minus I. So how do I graph that?
over 1 down.
And here is my resultant. Okay, 6 points. You can do that. Okay? Pretty good? Pretty easy?
Yeah.
Do we have to draw like the dotted line to connect?
No, you don't. All right, so I want you to try 4 plus 2i minus 3 minus 3i. Okay, I want you to graph the difference of the two complex numbers. Okay, so graph the originals, graph the resultant. Let's see how you... Okay, when you subtract them, what do you get for the difference? 1 plus 5i. Good. So your result should look like this.
Oh, that's weird.
Yeah.
See, that's what I got, but I didn't think it was right.
Yep, that's right. Subtraction's a little different looking. Okay?
What did I do wrong?
Yeah, I guess I'm good.
Did you subtract incorrectly?
When I
Because this is keep, change, change.
yeah, that's
Yeah,
what
I changed the point, so I did the point negative 3. Oh, okay, you don't change points.
You don't change the point. Don't change the point. Okay, I want you to try one more. Okay, sum.
Will there ever be like multiplication?
Not for graphing.
Okay.
If I had 2 times 2 plus I, this would be, here's your vector. If I wanted the result after that, it would be 4 plus 2i. So it would be this. Just doubles it, doubles the magnitude.
You said we have to label the axes on the equation, right?
Uh-huh. Everybody get something that looks like that? Huh? This is something else. I do want to talk about that real quick. If they ask you to graph something, if they ask you to graph 2 plus I and then like what the product of 2 and 2 plus I would be, all you would do is, here's 2 plus I, right? 2 times that would be 4 plus 2i. So there's 4 plus 2i. That's all that would be. It's just doubling it. Okay? Okay, homework, worksheet, all 10 questions. Addition, subtraction, multiplication, all by hand. I want to see you foiling. Division and absolute value you can do on your calculator. The last problem there is just asking you to graph that vector. The 12 was the problem number. You can cross that 12 off and it's nothing to do with the